Hello everyone. Today we will be discussing on Introduction to Fluid Mechanics. Let us first start with what is fluid. It is defined as the substance which deforms continuously under the action of tangential force regardless of its magnitude. See the term deform here. In this context, deforms means to flow. In science, we know that deformation means change in size or shape of an object. But here we understand deformation as the flowing property of a fluid which indicates how much it resists. Let us try to understand this in simple terms. Let us assume a certain volume of water, let's say in a container. So here what we will do, we will apply tangential force on the surface of water, and we will observe that there is a continuous deformation on the surface of water. The deformation is due to the application of tangential force here. So we can say that the substance which deforms continuously under the action of tangential force is known as fluid. I think the definition of fluid is clear. Let's discuss the types of fluid. Fluid is of two types. First one is liquid and the second one is gas. Let's discuss the comparison between liquid and gas. The comparison between these two fluids is based on molecular arrangement and their behavior. The first comparison is the molecules of a liquid are very closely spaced as compared to those of a gas. Second comparison, a liquid has a free surface and occupies a certain volume in a container, but a gas does not possess a free surface and fills the space of the container regardless of its size. In simple way, we can say that liquid have a fixed volume but no fixed shape, and gas have no fixed volume as well as no fixed shape. The third comparison, for all practical purposes, a liquid is incompressible in nature, whereas a gas is compressible and expands unless contained or enclosed in a container. Or we can say that gas expands till the space is available. Next we discuss the definition of fluid mechanics. Already we understand what is fluid and we know what is mechanics. Mechanics is nothing but that is the study of an object in rest as well as in motion condition. So here what we consider the object or the substance, that is fluid. So here we study the behavior of fluid in rest as well as in motion condition. So it is defined as the branch of physical science which deals with the behavior of fluid at rest and in motion condition. So next we consider fluid continuum. So from the name itself, we try to understand what is fluid continuum. So see, we know what is fluid, and this continuum means continuous. So what continuous here? Here we consider the mass distribution within the substance is continuous. So see, if the intermolecular distance between the particles are very small as compared to the characteristic dimensions, then the fluid can be considered as a mass of continuous medium, and you can apply macroscopic study on the fluid content. So here basically we discuss about the continuous distribution of the mass within the substance. Let us try to understand this in simple way. Let us assume any of the substance within which molecules are arranged in such a manner. Here, practically what we observe that there are voids present in between the molecules. These voids are assumed to be the intermolecular distance between the molecules. The intermolecular distance is very small. So, we neglect the intermolecular distance between the molecules and we assume the mass distribution within the substance to be continuous. So, here we will follow a macroscopic approach to study, where we study taking the average value into the account. We will not study at molecular level or at microscopic level or microscopic approach. So here what basically we discuss that the mass distribution within the fluid is continuous. So this is all about the fluid continuum. Next we discuss on properties of fluid. The first property we will discuss is density. So density, or it is also known as mass density. The density of a fluid is defined as the ratio of the mass of a fluid to its volume. Density is denoted by the symbol rho. So mathematical expression is rho equal to m by v. So m is what? Mass of the fluid, and v is the volume of fluid. The SI unit of density is kg per meter cube. We have to remember some densities of some standard fluids like water. That is, density of water is 1000 kg per meter cube or 1 gram per centimeter cube. Density of liquid is constant, but density of gas varies with pressure and temperature. So how the density of liquid is constant and density of gas varies with pressure and temperature, that we will discuss in the later videos. Next property we will discuss is specific weight or weight density. It is defined as the weight of a fluid to its volume, and specific weight is denoted by the symbol small w. It is written as small w equal to weight of the fluid by volume of fluid. So this will be from the definition itself. Weight of the fluid can be written as the product of mass of the fluid and acceleration due to gravity. So mass of the fluid is denoted as m and acceleration due to gravity is g. Volume of the fluid is denoted as capital V. So small w equal to mg by v. And see, here we have an expression that is m by v. So in place of m by v, we substitute m by v as rho into g. So rho equal to m by v. So SI unit of specific weight is Newton per meter cube. So if I say specific weight of water, so it is 1000 into 9.81 Newton per meter cube. So this is from the value that is rho into g. So g is 9.81 and density of water is 1000. So next we will discuss specific volume. So specific volume is defined as the volume of a fluid occupied by a unit mass of a fluid. It is denoted by the symbol that is small v. So small v equal to volume of fluid by mass of fluid. Volume of fluid is denoted with capital V and mass of fluid is m. So we know that density equal to rho equal to m by v. So here we get the expression v by m. So in place of v by m, we can consider it is 1 by rho. So SI unit of small v, that is specific volume, is meter cube per kg. Specific volume is commonly applied to gases. So this is one of the most important point which you have to remember. So next property we will discuss here, it is specific gravity. It is defined as the ratio of the weight density or density of a fluid to the weight density of a standard fluid. See, weight density of fluid to the weight density of standard fluid. So fluid, here we can take any of the fluid. But standard fluid, we have to consider for liquid, it is water, and for gas, it is air. So air is the standard fluid for gas and water is the standard fluid for liquid. Specific gravity is also known as relative density, as the specific gravity is the ratio of two weight density. So it is a dimensionless quantity. And specific gravity is denoted by the symbol that is S. This is all about the today's lecture. Thank you.